Now let's shift our focus to testing for similarity. Notice how these tests are similar to congruent tests, but there will be some crucial differences. Let's look at AA. If two corresponding angles are equal between the two angles, then the triangles are similar. This is actually simple than congruent testing, because if two angles are equal, the third angle must be equal. Since all the angles are equal, the triangle must be similar. They will have the same shape even if they have different size. Next, we have SAS or similarity, but notice the key difference from congruency tests. As again, we need one included angle to be equal, but the two corresponding sides need not be equal. They just have to be proportional. For example, if one triangle has side of 6 cm and 9 cm with a 60-degree angle between them, if another triangle has a side of 4 cm and 6 cm with the same 60-degree angle between them, they are similar because the ratio of the sides are 6:4, which is equal to 3/2. And finally, we have the SSS test for similarity. All the sides must be proportional with the same skew factor. Unlike congruency, where sides must be exactly equal, here we are just looking for consistent ratio. If triangle 1 has sides of length 6, 8, and 10, if another triangle has sides 3, 4, and 5, they are similar because each side of the second triangle is exactly half the length of the corresponding side in the first triangle. The key insight is that similarity test is more flexible than the congruency test. We are looking for the same shape and any size, so we are looking more for proportionate relationship and equal angles. You don't need the exactly equal requirements that congruency test usually demands. Let's look at the angle-angle similarity test, which is the easiest and most simple method for proving similarity. Look at the triangle ABC in green and triangle EGF in pink. If we know that angle ABC equal to angle EGF and angle BCA equal to angle GFE, we can say that ABC, the triangle, is similar to the triangle EGF. How about the third angle, you might ask? Remember that a fundamental property of triangle says that all sums of the angles in the triangle is always 180 degrees. If we have two angles that are the same, then the third last angle must be also equal. Therefore, we can conclude that triangle ABC is similar to triangle EGF using the angle-angle similarity test. The AA test is very useful in practice. Angles are usually easier to identify and to measure than the side lengths, especially in geometric diagrams. Now, let's examine the side angle side similarity test, which combines both the proportional sides and equal angles. We have the triangle ABC in blue and the triangle DEF in purple. The elements we need to check are as shown. First, you have the included angle, angle BAC, and angle EDF. This must be equal for the SAS to work, and then we need the sides. We need the two corresponding sides to be proportional with the same ratio. To get the equation, we need to have AB over DE equal to BC over EF. This means that the ratio between corresponding side AB and DE is the same as the ratio between corresponding side BC and EF. For example, if AB is 6 and DE equal to 4, we have a ratio of 6/4 or 3/2. Then BC and EF must also have the same 3/2 ratio. So if BC is 9, then EF must be 6, so that 9 equal to 6 corresponds to 3/2. Now, here is the SSS similarity test. This test requires all the three corresponding sides to be proportional with the same skew factor. It's a bit like the SSS congruency test, but instead of having them to be equal, we just need them to be proportional. Looking at triangle ABC with side 10, 12, and 14, and triangle DEF with sides 5, 6, and 7, we can check if they are similar by calculating the ratio over the corresponding side. Let's try to find AB over DE, that is 10/5, which is equal to 2. And we check that BC over EF is 12 over 6, which is equal to 2. And lastly, we have AC over DF, which is 14 divided by 7, which is 2 as well. Since all these three ratios are identical, we can conclude that angle ABC is similar to angle DEF using the side-side similarity test. In the example, we can conclude that triangle ABC is similar to triangle DEF. This means that triangle ABC is exactly twice the size of triangle DEF in all dimensions, but they have identical shape. If you were to shrink triangle ABC by a factor of 2, they will be congruent.
Smash your maths exams. Download Learn Maths Today for real exam questions and achieve top marks.